So OLAP cube means, so it's a multi-dimensional data. Okay, multi-dimensional data. So how are we looking at the data in the data warehouse? Okay, if you take, so this is the cube, and so how are we looking at this particular data in the real time? Okay, so OLAP is based on the multi-dimensional data model, and it enables a user to easily selectively extract and view the data from different point of views perspective. So helps in decision making for business process. Okay, if you look at this one, this is just a imagination only. Data we will not load it in this way, just imagination. We have the product table. If you take, this is the product table, right? And supplier table and the category table. So we will have this table. For example, I explained this data model, right, previously. So I'm looking at the same data only, product information, employee information already we loaded. But your customer is asking some information. Okay, I need country-wise top three selling products. Country-wise top three selling product. Then I will take country table, I'll take product table, sales table, right? Okay, this is one perspective. The other perspective, they will ask quarterly sales, quarterly sales, okay, for country wise, something like that, quarterly sales, right? Or they can go for, okay, some employee wise, employee base, or store wise. They can ask questions, right? Store wise, so what is the sales value? Product wise, which product is selling more? Okay, customer wise, premium customer or temporary customer, like one time customer, something like that. If you take Netflix and all, we have a different subscription model, right? Okay, based on the subscription model, what is the sales value? We want to analyze it. Same data only, but different direction we are viewing the data. So that is nothing but cube. Okay, cube, OLAP cube. Sometimes in interview they will ask this question. So what is OLAP cube? So how are we looking at the data? For example, I'm taking category. So category, we have three different categories here. So that category we are making here. Okay, category. Just for our imagination, that's it. We are not going to load the data in this way. In this way, we are not loading. This way only we are loading. But how we are viewing the data? Okay, I need this particular category wise sales. So this dimension, this way beverages, what is the sales, and other categories I want to know the sales value. So I can go for this way, right? And I can go for another dimension. I'm looking at one more direction. This is, in this direction I'm looking at top view. This is side view in this data model. So this is ultimate date dimension, and this is category. Sometimes we'll go for product also. Okay, category wise, January, February, March, April. See, we are not loading the data in this format. We are loading the data in the date only, date. But if I need a January month, what is the sales? Date, I have to do the aggregation, right? Month wise, quarterly. Okay, after month wise, I have to go do the summarization. So quarterly, January, February, March, I have to do the one quarter. So this is another view of data. Okay, so quarterly, monthly, even date wise, week wise. So all this I can look at, right? But I will store the data based on the date only. So date and time. But I can do the calculation, aggregation, right? And here I'm going for the measure. Okay, in stock, on order, sales amount, sales cost, sales quantity. These are the measures. Then I can find, okay, this particular category in this particular month, and what is the sales amount. I can see that's this, right? So this is one view and different view. For month wise, product wise, what is the sum of sales? It is not for one particular sales value. For all sales amount, I have to look at. So this way I can do different kind of view. So this is nothing but OLAP cube, sometimes nothing but multi-dimensional view of data in the data warehousing environment. Okay, example. Similarly, if you go to this one, Q1, Q2, Q3, Q4, then territory we are making US, Australia, and products, right? Different view we are making. This is also one of the interview questions they will ask. We have four types of analytical operations. What are the four different operations we will perform in the aggregation level? So if you go to any real-time project, they will say like, okay, do roll-up activities, drill down activities, slice and dice, and pivot operation, right? This kind of word you'll hear it. Roll up. Roll up is nothing but summarize. If you have date-wise sales, you are summarizing and you are finding monthly sales, weekly sales, quarterly sales. Okay, that is nothing but roll up activity. Drill down means they have given quarterly sales, but your customer asking, I need a month-wise drill down. You have month-wise sales value, but they are expecting again weekly sales or day-wise sales. Then you can identify, right? If you have the data with date wise. So that is nothing but drill down. Slice and dice means, so instead of looking at all the dimension, all the fact, you are looking at some portion only. So that is one, and then you are transposing the data. Pivot is nothing but transpose. If you go to roll up, for example, if you take this particular model, so we are the Q1, Q2, Q3, Q4, right? We are the category here, books, shoes, and then clothes, PC, and everything we have. And we are the New Jersey, Los Angeles, and different cities we have, right? Perth and then Sydney. So these two are from Australia, these two from USA. But your customer is asking, I need USA sales value. So what we have to do? So we have to combine these two, right? This 440 plus this 1560, if you add, this will become 2000. So this is nothing but roll up activity, roll up on location. Okay, location, rolling up on cities and getting the country-wise sales value. And sometimes if you have the country-wise sales value, if your customer is asking drill down, so from here you will drill down with city-wise. Even if you can go for store-wise also. That is one more level of drill down. So here you have a queue and you want to drill down, you can go for monthly. So that is nothing but drill down operation. If you see here, so this is Q1, Q2, Q3, Q4. We are viewing the data. So if you add 400, this 400 is this one, 150, 100, 150. So we are splitting. So that data. So that is nothing but drill down. So these are the operations we will perform on the data warehousing environment based on the data model. So whatever the aggregation we will do, if your customer is asking, okay, what kind of aggregation you will do? Yeah, we will go for some drill down operations and roll up activities the way a customer is asking. So that's what we will load the data into dimension fact table. Slice and dice means, so we are the cube. From the cube, we are taking one slice. That's it, one dimension, city wise and category wise. We are not going with any time or time dimension here. Just we are taking one slice. Dice means from the entire cube, we are taking only one simple cube. That's it. One location, Q1, Q2 alone. So this is a simple dice from large cube to small two-dimensional cube. And pivot means rotating, like a transpose. So these are the different operations we will have in our data warehousing environment. They will ask sometimes in interview. So what kind of operations you will perform? If you go to any real-time project, the data model will be done by some tools, data modeler by using some tools like Erwin Data Modeler or some other tools. So we do have. So I worked one project, Erwin Data Modeler. So that time we have to do data model and ETL also. If you go to any data warehousing project, first we will do the data model. So data modeling team, separate team, ETL team is separate team. After data model team, after they are creating the data model, that tables, how many tables we should have, and what are the information we have to collect from the source system, and how to load all the data. So how we can define the interrelations, RDBMS model. So that is nothing but this model. So how they will, first of all, they will create. So final model is called physical data model. In order to go with this physical data model, first they will go for different stages. Conceptual data model, logical data model, and physical data model. These are the three different steps involved. If you go to any solution architect or data architect, so they will do this kind of activity. First, what they will do, they'll go for conceptual data model. It's nothing but there is no software is required. Just they will take notepad or even Excel sheet. So they will define, okay, how many tables are needed. I will get a time dimension, that is date dimension, product dimension. I need different store. I need the sales. So they will put all the tables without any column names here. So just a table names and how it is relating with each other. So this is called conceptual data model. First, no attribute. So you know, right, what is attribute? Attribute, if somebody is saying that attribute, it's nothing but column name. Okay, so column name, attribute. Entity means, so entity is nothing but tables. Okay, so table. So table is called entities. So how many entities are here? Four entities are there, right? So four tables. Entity relationship model. So that's what we'll call it as ER model, right? So ER model means how these entities are related with each other. So that's nothing but entity relationship model. So they will create no attribute is specified, no primary key is specified, right? So primary key, foreign key, we are not specifying in this model. Okay, this is conceptual model. This is no software is required, highly abstract. It is a very highly abstract and no software tool is needed. Okay, and after that they will go for the logical model. Logical model. Logical model means after creating that, they'll, okay, so in this time dimension or product table, so what are the different columns are needed? Okay, product table, product ID, then product information. Similarly for store table, store ID, and this one. So which one will be the foreign key, primary key, all this they will define. Do we need any software tool for this? Yes, we need the software tool. Normalization also we will put this way, foreign key, primary key, everything will put. So this model will call it as logical model. Software tool is needed. So that software tool you can go for, so Erwin or Power Designer. So sometimes in Informatica also you have Power Designer tool, right? Informatica Power Designer also you can use, or mostly we'll use Erwin, the real-time project Erwin tool. We will define it. So why we are defining it? After defining it, we will go for physical data model. So every column we will define the column data type and data length and primary key, foreign key relationship, everything, constraints, everything we will define. And from the tool itself, we will connect to the database. Okay, it may be like Oracle database or whatever the database we are using. We will connect to the database and we will simply say like create data model. Based on the relationship, it will automatically go and create. Okay, which table should be created first? Finally, it will create the fact tables. It will create with the foreign key, all this. So just we will connect in the backend, create this data model. It will go and create all the tables for us. Okay. So this is what the first time from the scratch they will create. But most of the project, 90% of the project, we will have this data model already. And in addition to that, we will add some columns. We will add one more table. That's it. Okay. Some tables we'll add it. We will not change this data model. Or sometimes without relationship also, we will load the tables and we will create relationship after that also. Okay. So what kind of tool they will use? Erwin is the tool. So if you open this right page, you can close it. Now you can go to this one. So this is what you have the field, right? You have the data sources here, field, visualizations and filters, all this. This is on the reporting. First, you will go for the data model. So here we will have the relationship, how these tables are related, that we have to give here. It will not automatically create. So we have to go and create this connections. Okay. If the database level, say for an example, I'm going to connect with the Oracle database. So go to get data. So I will create the tables are there in the relationship in the database. I will go to the more, click on more. I want to connect with Oracle database. So click on more here, then go to the database. So here we will have the how this model will take place. That is what I want to explain. So I will go to the Oracle database, choose the Oracle database, connect. So this Power BI will ask, okay, what is the credential for this particular database? I will give local host. So if you want to apply some queries, you can apply some queries also here. So I'm not applying any queries, just I'm making that. I'm applying the connections. Just we are making here like this. It has been connected. Okay. So Microsoft has been connected. So if you look at here, I will go for HR schema. The schema tables. So tables and views, everything will be there. Okay. So I will go to the, so tables, not view. So I'll go for something called tables. So this table I will take, employees table. So the employee table will have the employee ID, first name, last name, email address, everything. It has one column like department ID. This department ID. It is there in the relationship. That is why it is bringing HR, department table, department ID. So we have the department ID, 90, all this value. So this will be related to other tables. What is the table? Departments table. Then this department table related to another table. So even locations table also, job history table also. So I will take locations table. So I'm going to load this. The database, we have the relationship. Okay, employees table, departments table, locations table. How this will be taken in Power BI? Look at now. The Power BI is loading the data. It will create the model now. See here, creating connection in model, loading data to a model. It has been loaded with. Okay, so how many number of records we have? It has been loaded. So it will show you now. Here, this is what will have the data model. Okay, you can have this, how these tables are related. You'll have the employees table. So first of all, you have the employees table, then departments table, locations table. The hierarchy is first we will create the locations table, then departments table, then we will load the employees details. So that is what the hierarchy we have. See here the relationship you can see here. So this is the relationship, departments dot location ID equal to locations dot location ID. The same way here we have departments dot department ID equal to employees dot department ID, and we have one more connection also. This employee ID is related to, here it is the manager ID. If you do not want this connection, right, you can right click on this connection, you can delete it. So only department ID is enough. You can have this connection. This one we can delete it. Okay, while deleting it, it will ask you. Then it will create the data model. If you look at here, so what is the meaning of one and the star here? So this is the relationship. So one is nothing but, say for an example, in one department. Okay, say for an example, I have department ID 10. You take the 10. So 10 is one time only, it will be present in the departments table. So that is the one department ID. One department ID, but in the employees table, multiple times it will be presented. Why? Why? Because in one single department, many employees can have many employees, right? So in one single department, we can have multiple employees, right? So the same department ID, multiple times present in the employees table. So this is what we'll have, department ID. One locations. So one location ID, say for an example, location ID 120 or 1200. For this location, okay, how many departments are there? Multiple departments. Okay, one single location, we can have multiple departments. So that relationship will be there in the database. So that is what it will automatically take. So automatically it will take. We are not going to do anything. So how these tables are related also. If I want to say for an example, it is taking only location ID, you have one more column to be joined. Then you can double click on this particular relationship, double click on this. If it has been wrongly mapped, you can map it correctly. So manager ID, you want to map it with the location ID, you can map it, but there won't be any data. So why? Because this is location ID like this. Here manager ID does something like this. It will not make join. Whichever the column you are choosing, that is what you have to choose. Tables and tables, what is the cardinality? So many to one. So this is what we will maintain the relationship, cardinality based on. So how many tables we are bringing? So that is what we will maintain.
Chandra, what is that summation symbol? I mean, the departments, right? There is a symbol before the manager ID. What that indicates?
Yeah. So normally the tableau will take a dimension and measure automatically. So this one is dimension, this one is measure. In Power BI, how it will take, right? So whatever the numeric field is there, it will take it like a measure. Whatever the dimensional values like department ID, department name, location ID and all, it is predicting that, okay, this is like a measure. Manager ID numeric number, right? It is taking like a measure. This is not measure. This is actually dimension. So we have to make don't summarize. See, these are all the dimensions, right? So here, employee ID is not a dimension. Commission percentage is a measure. Employee ID is a dimension only. Sorry, it is not a measure. Then we have the salary is measure. Manager ID we have to remove. So salary and commission percentage alone, we are going to make it like a summation. So other we can remove it. So we'll have choose the column. We can go for don't summarize. So that we will do it on the data side. So if you go to the data side, right? So you have the columns like summarization, this particular column. So this is the employee ID, all this column. So this column, if you do not want to summarize, then you have the do not summarize. Here we have. So if you make this particular summation will be moved out. If you do not want, so something like this will have. Anyhow, the date column will have all the hierarchy. If you look at here, date we have taken, right? So date, if you look at this particular arrow mark, date hierarchy, date will have year, quarter, month and day. All the hierarchies will automatically create. So date will always have the hierarchy. So all the field will be there in the data. So this is what the data model. Okay, I'm going to bring one more table. It is not related to this particular data model. It is not related to this particular model. How this model will be created? So there will be any relationship between this model and other model? No, there won't be any relationship. I'm going to bring the table in Excel workbook, the source. So whatever the data we have, say for an example, I will have the data. Even I can take some other data also. Here I will go for data source. This is sample superstore I'm taking. This is for even common for Power BI as well as Tableau we can take. So we have other data source that is also we can take. So open. So if I'm going to take this one, right? Sample superstore. Okay. Some Excel sheet workbook I'm getting some error. So this particular data set has some error. So instead of that, I will go for some other data. Sales data I want to take. So this is some data. We have Excel sheet. In this we have 5 different sheets. So in single workbook, we have 5 different. So customer, employee, locations, product. These are all the dimension tables. How these tables are related with the sales table. So this is the fact table. We can click on load. It will get automatically loaded. If you look at here, all the 5 tables have been loaded. Since it is a flat file, it got loaded very easily, very quickly also. See, automatically, based on the relationship, it will make the data model based on the column name. See, there is no relationship between this one and this one. This one is separate data model. This is separate data model. So if you look at here, there is one wrongly it should have mapped. Say for an example, location table and the sales table. So which column it has been mapped? So here ID column. Okay, it is taking the ID column. So this ID column we have location ID. So here we have the column called ID column. So this ID column should be mapped with quantity, product, and location ID. So location ID only should be mapped. Since we have taken the ID column, right? Since we have taken ID column, so this ID column is related to some other ID here. So this ID, sales ID. So this is sales ID actually. This is location ID. Since we kept ID column called ID, sales ID called ID, this ID column is mapped with this ID column. But this is wrong actually. The data model should be in location table, we have the location ID. In sales table, we have the location ID. That should be mapped correctly. This is wrong actually. If you go and check the data, there won't be any joining of these two. This is sales ID, this is location ID. So double click on it. We have to change the model. Okay, this ID. In location table, we have ID 1, 2, 3. Here, look at here 35 402. This will not join. Then we have the location ID here. Join with this table. So location ID equal to location ID. Click on OK. Now the model will change. We'll make the joins based on this value. You look at here. This is what you can able to see the data. ID column, location ID. So this is what data model we will take it. So we can take n number of data model here, n number of tables here, n number of data models here. So each table, how it will be related. Here we have the date and time data type. So this is aggregation value. So this is also aggregation value. Whenever the numeric value present, then summation value will be present here. A multiple column, so you have to have the relationship of multiple columns.
Just one more question. Like, I mean, when we create this model, the data gets loaded, right? So is it mandatory? Like every time we need to load the data, like because in the real time the the volume will be huge, right? So
yes, every time we have to load. See, whenever we are going to do, so one time, so very first time you load, that's all. It will take some time. That is what the Power BI will take some time, definitely. Performance wise, and compared to Tableau, Power BI will take a lot of time. If it is native database, right, Microsoft SQL Server, then it will connect it very quickly. But other databases, it will take time. Definitely, it will take time. So we will have something like extracting the data into a server. So that we will see in the server level concept. While publishing, we have to extract the data. So we can extract it and schedule it. So once in a day or 1 hour once in a day. So we will schedule it, the data refresh. So Power BI will go and refresh the data. In Power BI server, it will save the data. So all the data will be captured, extracted, and it will be stored in Power BI server while publishing it. Okay, we have the publish option, right? While publishing it, it will export the data from here. It will load into the Power BI server. From there, we will take it as a. Then every day we have to frequency, based on the frequency, we have to refresh the data.